Welcome to Engine Power and part 2 of our big 512 cubic inch Mopar build. Today we're finishing it off and headed to the dyno. Now the short block went together really nice. That was due to awesome machine work and parts that were scienced out to work together. Now in case you're just jumping on the wagon, here's a look at how it all came together. The 440 block was pulled and shipped to us from Stevens Performance, who specialize in Mopar parts. We sent it to Shacklett's Auto Machine where it got prepped for our assembly. Here's what they did.
After a few days at the machine shop, our Mopar's foundation is back in our hands. While at Shacklett's Automotive, our block was line honed, which gets all the main bearing bores aligned and sized. We supplied these ARP studs because they had to be in for this operation. Anytime that you switch from bolts to studs, it will distort the main cap differently due to the way that the fastener actually clamps the cap. Then the decks were equalized, which puts the height and plane of the decks equal distance to the center line of the crank. After that, the cylinders were bored and then honed using a torque plate, which gets torqued to the deck to simulate a cylinder head installed. This allows for the cylinder to be honed in a controlled manner to maintain proper bore geometry. All the machining steps were done in top-notch fashion, which goes to show that Shacklett's is a quality machine shop. But before we can put it in the cleaner, we still have a little bit left to do. And since this is going to be a 512-inch racy street bullet, we're going to treat it accordingly. By deburring the entire block and opening and cleaning the oil passages. We started assembly with a forged steel Platinum Series crankshaft with a 4250 stroke from the 440 source. A custom ground camshaft went in, along with a multi-keyway timing set. Then dropped in our forged H-beam rods and pistons to complete the rotating assembly. The oil pickup screwed into the block. Then the factory timing cover went on. The windage tray was positioned and a 7-quart low-profile oil pan sealed up the bottom end. An SFI balancer was installed and the external oil pump was bolted on.
Pat and I predict this engine will make north of 600 horsepower and do so on pump gas. Now the measured compression ratio is 10.8 to 1. The cylinder heads are a hot topic for this build. That's because Trick Flow Specialties saw a huge gap in the availability of a high-flowing, direct bolt-on head for big block Mopars. But they came through with these brand new released PowerPort 240s. Their CNC'd intake ports measure in at 240 cc's. And the exhaust measures 74 cc's. They're also CNC machined. The valve sizes are 2190 on the intake and 1760 on the exhaust, and they're both housed in a 78 cc combustion chamber. Now these heads are designed to work with stock style valve train and pistons for a true bolt-on application.
Complementing the camshaft are Comp's retrofit hydraulic roller lifters. Always install them after a pre-soak to ensure the needle bearings are lubricated and no air pockets are in the plungers. We calculated our compression ratio utilizing a 27 thousandths compressed head gasket. These are multi-layer steel design from Cometic. Now the head can be positioned and ARP head studs can be installed. Doing it in this order will prevent any aluminum from being transferred to the stud on the cylinder head installation. ARP Ultra Torque Lube will ensure the studs are torqued properly, all the way to 80 pound-feet. The next step we like to do is determine the pushrod length. For that, we have to use our rocker arm setup and an adjustable pushrod length checker. At its minimum length, snake it into position and run it up till it seats on the rocker adjuster. Then remove the rocker assembly, carefully remove the checker, and measure its length with a caliper. We'll order some 9300 pushrods.
The build continues after the break. Stay with us.
We're back. It's been a day since we worked on our 512-inch big block Mopar. That's due to having to order a custom set of pushrods from Trend Performance, who next day aired them to us. It was a company that was started by Bob Fox, who, along with the late Randy Dorton, created the Spintron machine, which is the benchmark for valve train evaluation and testing. These have a 3/8 of an inch body that has an 80 thousandths wall thickness. On the rocker side, it has a 5/16 cup, and on the lifter side, it has a 5/16 ball. The length, 9300. For installation, make sure to have both ends lubricated with a high-pressure lube like this CMD we get from Goodson. Now position them on the lifters, making sure they are seated in the plunger. When it comes to affordability, durability, and longevity, it's hard to beat a Harlan Sharp shaft rocker setup. This is their heavy-duty set for B and RB big blocks, and Summit Racing sells them for $786. They're specifically designed for heavy spring pressures and high lift geometry of modified engines. A wide rocker body is used for increased strength and longevity. We're setting them up at half turn past, 0 lash. These have a 1.6 ratio, which puts a total lift at the valve on the intake side at 640 thousandths and 672 thousandths on the exhaust. To seal up the void of the lifter valley, a factory-type valley tray is used. Take your time prepping it. A good seal here is mandatory.
To complement TrickFlow's new cylinder heads and to finish the top end off on this engine is this TrickFlow single-plane track heat intake manifold. Now this thing has extra long runners and a raised plenum floor for additional horsepower and torque. It has an operating range from 3 to 7,000 RPM, and check this out. They even cast bosses in the intake runners for nitrous nozzles.
It has plenty of material for port work, but we're running it as cast to show you what it's capable of out of the box. The Summit Racing cast valve covers with a polished finish can cover up the valve train. They are a tall design, so we won't have any interference issues with the rocker arms. To reduce power-robbing parasitic drag, we're running this Mezier high-flow electric water pump. It flows 55 gallons per minute and is backed by their 2-year unlimited mileage warranty.
Since Pat and I decided to run EFI on this engine, a fuel pump block-off plate is being installed. The rest happens in the dyno room. It's docked up to the dyno, and we're pumped to hear it run. But a few things are needed to do so. Mopar 440s don't have a distributor gear on the distributor shaft, so we got this set up for Mopar Performance that already has a bronze gear installed.
It's hard to beat an MSD Pro Billet distributor. They have uncompromising quality and they're very user-friendly to modify for your needs. Case in point, we locked out the advance on this one and we showed you how to do it. Locking it out eliminates the mechanical advance, so you have total control over the timing at every RPM. This is common practice on high-performance street and full race bullets.
Listen up, everyone. This is a new product we're super excited to try out. It's a Phytech electronic fuel injection system that's packed full of features anyone with a street car or race car can use. Now, this unit is a direct replacement for anything with a 4-barrel carburetor on it. It's also a great addition to late model engines like Hemis or LSs that have already been swapped over to a carbureted type intake manifold. Now, this unit will support 250 all the way up to 1,200 horsepower. You heard me right, 1,200. Now, that's all thanks to 8 high-flow injectors that are mounted into the throttle body. It's boost ready right out of the box to support up to 25 pounds in a blow-through application or a Roots type supercharger setup. It has a built-in 2.5 bar map sensor. The fuel pressure regulator is built in as well, so you won't have to mount a remote one. And the ECU is mounted here to eliminate something else to mount and bulky harnesses to hide. This system also features several important control systems, like a built-in 8-gig data logger, along with boost and nitrous timing retard strategies and air-fuel target options. Now, it can be used with an MSD6AL or any other CDI ignition box, but it's not needed if you're running a plug-and-play distributor like we are. Now, it also has a built-in voltage-controlled fuel pump controller, and all of that stuff I just talked about can be changed on the fly on this touchscreen monitor. Now, the coolest thing about this whole system is it's self-learning. You don't have to have tuning experience, and it has a very fast learn rate based off of a 4.2 Bosch wideband O2 sensor. Now, when we come back from the break, you'll see it all hooked up. We're back and ready to get our Phytech EFI installed, starting with the temperature sensor. We're placing it in the water pump because Mezier set this one up for one. Big cubic inches require headers with big primaries. These are Hooker Super Comps with 2-inch primaries that merge in to a 3.5-inch collector. They are ceramic coated and work great as dyno headers or in B and E body Mopars. Now it's time to drop in the Bosch wideband O2 sensor. Now Phytech supplies this O2 bung that makes it easy to mount the sensor if you don't have a welder. First, drill a hole big enough for the sensor to reach inside the pipe. Now position the supplied gasket and bung over your hole and tighten it down with supplied clamps. Now we can screw in the sensor, tighten it down, and make its connection. Now we can connect harness A into harness B on the Phytech unit. This houses all the loose connections for the power hookups and ignition. For our engine setup, we only need 3. The white wire goes to a switched 12-volt ignition source. The black to the negative side of the coil since we're using the Phytech timing control. And heavy red directly to the battery. Now plug the Phytech 2-wire distributor connection right into the MSD distributor.
Whether you have a top fuel dragster or a clunky little lawnmower, E3 makes a spark plug for it. We've had great results using them, so they'll like the air-fuel mix in our big block Mopar as well. MSD 8.5mm spiral core wires will channel the voltage down to the spark bolts. Now the handheld monitor is plugged in and the system is powered up. Make the selections and set the parameters for your setup, and we are ready to light it off.
And that's exactly what we've all been waiting on. Now we're going to run this engine on 93 octane pump gas. It's got a 10.8 to 1 compression ratio, and we're starting the timing out at 30 degrees. Now as we progress through the runs, we'll bump up the timing as well as the RPM. Now back in the day, this 440 made 380 horsepower. So let's see what the Phytech EFI and 512 inches of Mopar madness can crank out. We ran it for several minutes to get it up to operating temp, so the injection could do its thing.
Gotta start somewhere, so let's start here.
All the vitals are good. Here we go.
All right.
This initial pull is from 3 to 5,500 RPM to make sure everything is in check.
I saw some excellent torque right there.
Yeah, I felt it.
Nice.
Wow.
Look at that.
621 on torque, 599 on power.
Almost cracked 600 the first shot on that self-learning Phytech.
Yeah, that's impressive.
Step up the RPM to, let's go 3,500 to 6,000, and we'll start making some real power pulls.
Now you can see the excellent fuel delivery pattern of the Phytech EFI. Watch what happens at wide open throttle. Man, this thing feels awesome. 604 on power, 626 pound-feet.
Excellent start.
Let's start making some snot.
Timing. So we'll take the timing from 30 to 32 degrees, and we're confident we're gonna see a change. But you'll see that after the break.
Hey, if you had a dyno, you'd play with it too. Stay with us.
We're back and ready to pull more out of our big inch, big block Mopar. Let's roll. We bumped the timing 2 more degrees to 32. Might have snuck a little more in her.
609 on power, 634 on torque.
All right, very nice.
And look, I mean, this thing comes in hard too. It's making 600 foot-pounds at the start at 3,500.
Yeah.
I say let's find max timing and then see what we can do with a spacer.
That's how you tune. With 2 more degrees, we're at a total of 34.
35 to 6, keep it the same.
Yep. Sneaking up on it. We always creep up on the timing because every engine is different where the power and torque level off.
610 on power, 631 on torque.
We found our timing threshold, and that's a good indication of an efficient combustion chamber. Like a lot of engines here on the dyno, we're gonna try a spacer to see if we can pick up some power. This is a spacer that we got from Keith Wilson at Wilson Manifolds. Now Wilson is the originator of the tapered spacer way back in the 80s. This is the most knocked off part in the high performance industry. What it does, it adds some plenum volume and helps straighten the air, making a gentler turn into the runner. So we're gonna see if we can pick up some power.
All right, spacer added.
Same RPM, same timing.
This will be a good test.
You hanging on?
I'm ready. Well,
It liked it on the power side.
Yeah, it liked
Picked
it.
up 7 numbers.
well, that's what a spacer really does. It'll help it on the top side. 7 numbers, that's nice.
And the torque, interestingly, didn't drop or gain at all. 630.
Beautiful, beautiful. That's a nice piece. Would you want to know what it does against a carburetor? Let's give it a try.
Let's do it.
The Phytech blows any carb away when it comes to options, streetability, fuel economy, and cold starting. Plus, its self-learning feature is second to none. Comparing it to a fully tuned race carb is not apples to apples, but we had to see what it will make.
Same run, the only thing different is the carburetor.
Man, it's going to be an interesting one. Look at that.
631 on power, 643 on torque. That thing picked up a bunch.
It picked up a ton.
Man, what good torque all the way through.
Spectacular. No, it held great power. Let's see, yep, oil pressure looks good. Manifold vacuum looks good. Carries torque well. Excellent. Nice job.
Another good one.
Any level of engine build, from a warmed over stock power plant to a full tilt race bullet, can benefit from an upgraded rocker arm system. In today's tech tip, we're going to educate you on different rocker options, plus a little known setup that pro engine builders use you probably haven't heard of. We'll start by looking at stock replacements. These are a common type used successfully in OEM applications up until the late 1990s. They're a sled fulcrum style, meaning the rocker pivots on a ball or a rounded retainer. They work well in low RPM, low lift, mild performance applications due to their design, but they are limited in the performance department because they do not allow for high lift cams or heavy spring pressures. This is because they have metal-to-metal contact surfaces and insufficient travel for the increased pivoting on bigger cam profiles. An upgrade to that old technology is a roller trunnion rocker arm. To decrease friction and improve valve train geometry, the rocker body has a shaft in it that rides on some needle bearings. OEMs have implemented them in many applications, seeing the value of increased durability and valve train accuracy. The aftermarket has taken them one step further by incorporating a needle bearing roller that rides on the valve tip as well, decreasing friction even more. Rocker bodies can be made from extruded aluminum, cast or billet steel, or any number of exotic materials. Plus, they even have different rocker ratios available for most applications, so you can get more lift and duration without changing your cam. This style of rocker arm is great for street and strip, bracket race, and stock style circle track applications, but again, due to its design, it does have limitations on its usage. They must use a guide plate to keep the push rod located because they are still stud or bolt down mounted like a stock rocker. They can handle up to about 800 thousandths lift and open spring pressures of around 750 pounds, depending on their construction. For a no-holds-barred, high RPM, high horsepower, true race bullet, you need something with maximum strength, durability, and accuracy. Like these shaft mounts from Jessel, they convert your head from a stud mount to a shaft-mounted rocker by using a billet steel stand that bolts in place, and the rockers mount to the stand, providing a rock-solid foundation. Here's a little pro engine building secret. Flat tappet racing engines that require cam break-in are running with a break-in rocker, like this one with a lower ratio of 1.3. That keeps the spring pressure lower on the cam lobes, helping the cam establish a wear pattern more gently. Then they're switched out for the real rockers, and that's when the fun begins.
We hope you Mopar fans enjoyed this build as much as we did. Now, if you're interested in the Phytech EFI for any engine, contact Pace Performance and they can hook you up with the system you need. Now, to everybody else involved in this build, as well as everybody watching at home, thank you for helping us keep this performance industry alive.